Good morning, 8th graders. Today we are going to quickly review your chapter 5 since we did not get to finish that up before you guys left me. So I am going to go through your test review. You guys all received a copy of this when you guys got the packets delivered home. And so my plan is for us to do this together. I will give you guys an assessment on Wednesday, but today I just want you guys to focus on going through this and making sure that you understand the 10 sections from chapter 5. So I will go through this with you, and then you guys can ask me questions later. So the first section of chapter 5, we were just trying to identify if we knew if a function was linear or not. So I have some prompted questions here. What are the 3 ways to represent a function? So one way that we can represent a function would be a graph. We could have a table. And we can have ordered pairs. And we can have an equation. So there's actually more than 3 ways. So what's the difference between a function and a linear function? Well, the big thing that you guys need to remember is that a function and a linear function, they both are going to pass that vertical line test. So I'm just going to say both pass vertical line test, but the linear function has to create a straight line. That's the big thing with linear. So it has to be a line. Okay. So we practiced by looking at equations and ordered pairs in order to tell if they are linear. You guys, now at the end of your chapter, you probably can imagine what this is going to look like if we graph it, and we know that this is going to be linear. Okay, but this one, you could put in ordered pairs to check, and you could graph it, but there's a tell here. Anytime there's an exponent, you can't have square roots, you can't have absolute value, you can't have x and y being divided by each other, so you couldn't have, 2 equals x divided by y. This would not be linear, those types of things. So this one is not linear. Then we go on when they give us ordered pairs. I personally do not like to look at ordered pairs in a line like that, so I make a quick table. And with a linear function, the change between the x and y has to be consistent. So for example, this one went up by 2, then it went up by 3, then it went up by 3. So that was not the same. This one went down by 1, down by 1, down by 1. That's okay. Let's check our other one. So 1, -4, 2, -8, and 2, -12. Excuse me. Neither one of these would be linear, actually, because this one did not increase at all, and this one went up by 1, this one went down by a -4, this one went down by -4. So neither one was linear. This one we could have made linear if this would have been a 0. Then it would have had an increase by 3. And this one, if this would have been went to a 3, that would have been linear. So make sure there's that consistent difference. The difference between the x and y don't have to be the same, just has to be the same on the x and the same on the y. So the second section, we went to solving using intercepts. So the shortcut method, we called this the cover-up method. Okay, what does the intercept mean? It's where it crosses the x or y axis. So to find the intercepts, if I did this one, 5y equals 10. If I divide both sides by 5, my y-intercept is 2. So I would express this as 0, 2. It always goes in the y spot. Then if I did the other one, I would have 2x equals 10. Divide both sides by 2. X equals 5. Goes in the x spot. So your intercepts, you could go to your graph now and you could graph those two spots. Next one, remember if there's no number in front of the y, there's a 1. So in this case, it's a negative 1y equals 9. Divide by negative 1, y equals negative 9. 3x equals 9. Divide by 3, x equals 3. So your coordinates would be 0, negative 9, and 3, 0. Okay, in the next section, you were finding the slopes and rates of change. So when I am working on this, you could use the slope formula, but if we are just looking at a graph, I like to just count. Remember, you have to do rise over run, so you have to move up or down first. So I'm going to go down 1, 2, 3, and to the right 1, 2, 3, 4, 5, 6. So it'd be negative 3 over 6, which reduces to negative 1/2. The next one, I always work left to right usually. So on this one, I'm going to go up 3 and over 3 as well. They were both positive. So 3 over 3 equals 1. Then the last one here, 1, 2, 3, 4, 5. I went down 5 and over 1, so negative 5 over 1, which can be reduced to negative 5. Okay. Next page. You are going to find the rates of change. So remember, we are going to do the change of y over the change of x. Okay, dependent over independent. So you can find the changes real quick. So like 2000 to 2002 would be 2, 1, 2, 2. And I'm going to be going down here. Went down by negative 4, went down by negative 4, went down by negative 6, went down by negative 1. So when you compare these, you have to do how much did it change over how many years. So the first one, it changed 4. It went down 4 over 2 years. So it went down 4 over 2. So it was a negative $2 per 1 year. And the next one, it went down 4 over 1, so it was a negative 4 per 1. Then from 2003 to 2005, it went down 6 over 2, so that reduces to negative 3 over 1. And then the last one, it was negative 1 over 2, which when you simplify that is it reduced 0.5, half a dollar in 1 year. So when they want to know when the price decreased at the greatest rate, it might seem like it was between 2003 and 2005, but actually it was from 2002 to 2003 because it decreased at negative $4 per year. So rates of change are kind of tricky. You have to make sure that you consider each interval, especially when they're not spaced the same. Okay, I kind of wrote into my slope formula there. But my slope formula is y2 minus y1, which is the change in y, over x2 minus x1, which is the change in x. So it says find the slope of the line described here, find the intercepts, then graph it using the intercepts. So I'm going to kind of step you through a couple different ways to do these problems. So we're practicing with finding the intercepts. So if I found the x-intercept, I'd have 2x equals 6. Divide both sides by 2. My x-intercept is at positive 3. And then if I found my y, negative 3y equals 6. Divide both sides by negative 3, y equals negative 2. So your intercept is 0, negative 2. So if I go to my graph, 3, 0 is right here, and 0, negative 2 is right here. If I were to graph that, and I don't have a ruler handy, so I'm going to use the edge of a straight piece of paper. And now I can find my slope up from the graph. It's a positive slope. I go up 2 and to the right 3. So my slope is 2/3. Okay. Now going on to number 11, in section 5.4, you wouldn't have been able to find the slope just by looking at this. But now we've learned that this is the slope. So you don't have to do anything. You can just look at it like that. Number 12, we've got 2 points. Well, let's use our slope formula. I always like to label x1, y1, x2, y2. And let's plug them in. So y2 is negative 3 minus 2. x2 is 2 minus 1. Remember, if you're taking away, it's actually getting more negative. 2 minus 1 is just 1, so your slope is negative 5. Just be careful. A lot of mistakes are made because you guys are just a little too confident when you do that subtracting. We'll do one more here. 7 minus 2 divided by 2 minus 2. 7 minus 2 is 5. 2 minus 2 is 0. Can you divide by 0? The answer is no. So what happens here, this is an undefined slope. If you plotted these points, if you really think about this, let's just go over to our graph quick. 2, 2 is right here, and 2, 7 is right here. So this line would actually be straight up and down, which is that vertical undefined line. Okay, couple here, midpoint and distance. I jotted the formulas down before I started so we could just practice plugging them in. Again, I just do that x1, y1, x2, y2. So the midpoint is the average of your x's. The y is the average of your y's. So I'm going to have, I'll do it over here, negative 4 plus 5 divided by 2. And then I would have 3 plus a negative 6 divided by 2. Negative 4 plus 5 is 1, so this gives you 1/2. 3 plus negative 6 is negative 3 divided by 2. So these coordinates, when I'm doing a midpoint, I don't really like to express it as a fraction, so I just kind of switch these over to a decimal. So remember, midpoint, it's the point that's the middle between those 2 points. Okay, so distance formula, that's kind of the bigger one. The difference in the x's squared plus the difference in the y's squared. So x1, y1, x2, y2. Again, I know this doesn't seem very hard, but we make little mistakes when you don't add or subtract correctly. So this one's going to be 5 minus a negative 4 squared plus negative 3 minus 1 squared. And you guys might find mistakes as I'm doing this. Usually I have you in class to catch my errors. Subtracting a negative is actually adding, so this turns out to be 9 squared plus, and then I always add the opposite, so this is going to be a -4 squared. 9 squared is 81. Remember, negative squared always end up positive. So 81 and 16. 6 and 1 gives me 7, 9 and 1, or 8 and 1 give me 9, and then we're going to put this in our calculator. If you don't have a scientific calculator at home, you'll be fine. I'll show you my phone really quick. So this pulls up nearest hundredth is what they want us to round to, so this turns into 9.85 units. If you guys probably already know this, but on your phone, usually if you switch it to the scientific method, you'll have the square root there. I think on mine you have to put this in first and then hit, oh, nope, I lied. Some of them are different, but you can see it gives me the same answer. Okay? So even if you just have your phone or your iPad, you can still do those types of problems. Okay. Ooh, maybe we'll have to make this into a 2-videoer. I am going to pause this. My goal was to try to leave it in 15-minute segments. So this is going to be part 1. I will do part 2 in another video.